everyone, it's Mrs. Summer here to talk about lesson 201, slope-intercept form of a line. Make sure you either have your screen split so you can fill in the doodle notes using the Cami extension, or that you have printed out a copy of the slope-intercept form of a line doodle notes that are attached to this assignment in Google Classroom. The objectives for today are that students will be able to identify the slope of a line given the slope-intercept form of a line equation, identify the y-intercept of a line given the slope-intercept form of a line equation, write the equation of a line in slope-intercept form given the graph, and graph the equation of a line given the slope-intercept form of the equation. So if you recall from 8th grade math, slope is rise over run, or the y2 minus y1 divided by x2 minus x1. And I had this beautiful GIF all ready to go, and then when I inserted it in to explain everything, the tool I used to record the videos, the GIF didn't play. But if you think about it, with Super Mario, he has to jump up to hit that, and then he runs forward to hit this guy and eliminate him. So think about Mario jumping up first and then running forward when you think about slope. And if you recall, this is the y-axis, and this is my x-axis. So when we talk about rise, we rise up before we run out the door. So the slope is the rate of change So rise over run. Now you'll notice that throughout all of these notes, I am going to use the slope as being the color purple. The y-intercept is the point where the line crosses the y-axis. Slope-intercept form is a formula for the equation of a line using its slope and its y-axis. Y-intercept. So if you look, I colored in some of my lines. I'm using purple for slope and blue for y-intercept. So in this equation, it looks like y equals mx plus b, where m is your slope and b is your y-intercept. Okay. And x in this equation is a variable. The y over here is a variable. And this b is your y-intercept. We'll start by talking about steps for graphing and the equation of the line. So this example is try graphing the line y equals negative 3x plus 2. So number one is we start by placing a point at the y-intercept. So over on this graph, our y-intercept is 2 in this case. So I'm going to place a mark at 2. Then from that point, count out to find the next point. We're going to use the slope to count out. So the slope. Okay, be careful about your positive and negative signs with the slope. In this case, our slope is negative 3. So that means to get the negative, we're either rising up and moving to the left, or we're going down and we're going to the right. So let's start by doing this one. We're going to go down 3 and over 1. Because every time we can write or we look at a slope, if it's just a whole number, any whole number can be written as a fraction by putting it over 1. So we're going to go down 1, 2, 3 over 1. So we're going to put another point right here. We can go down again, 1, 2, 3 over 1. And on this, we can go up 1, 2, 3, and over 1. Then we're going to use those points to connect our line. And we're going to draw our arrows because the line goes on forever. Okay, and 3 is what we just did, and connect the points. So here's some practice using slope-intercept form. So write an equation for each line in slope-intercept form. So we'll start by looking at this one. Our y-intercept is right here. So we know that our b is minus 1. And our slope, we went up 1 and over to the left 1, 2, 3. So our slope is negative 1 over 3x. And I'm going to use this, negative 1 over 3x. And we're going to put y equals negative 1/3 over x, or 1/3 x minus 1. We started by finding our y-intercept, and we looked at other points on the graph to figure out our slope. On this example, we're going to start by finding our y-intercept, which is right here, and it's at negative 3. Then we're going to use the next point to figure out our slope. So we're going to go up 1, 2, 3, 4, 5, 6 over 1. So our slope is 6 over 1 x, and the equation is y equals 6 over 1x minus 3. We started by finding the y-intercept, then we counted up. We counted up 1, 2, 3, 4, 5, 6, and over 1. So we could just write that as y is equal to 6x minus 3. Now here's where we can graph each line. So it's giving us the equation. So here is our y-intercept at 4. So remember, we go 1, 2, 3, 4, and we plot our y-intercept. Then our slope is just negative 1. Remember, if there's no number in front of x, we assume it's 1, and it's negative 1 is our slope. So m equals negative 1, which means we can go down 1 over, plot our next point, down 1 over, down 1 over. We always fill up our entire graph with plot points before we draw our line. And then we can connect. And there's the line, or the graph of the line of the equation y equals negative x plus 4. If we go over to this one, now this one's a little bit trickier because it's not in y equals mx plus b form. So first, we need to subtract 1 from both sides. We're left with y is equal to 1 over 4x minus 1. Now we can plot our y-intercept at negative 1, and we're going to use our positive slope. We're going to go up 1 over 1, 2, 3, 4. And now we still haven't graphed or plotted our points on our whole graph. So we can go down 1 over 1, 2, 3, 4. Okay, and then we connect. Oops, we connect a little bit better. Okay, remember when we're graphing, you can go up and over, and that's positive. You can go down and to the left, which is also positive. And over here, you can do up and to the left, and that's a negative slope, or you can go down and to the right, and that's also a negative slope. So remember your directions when you're graphing your lines. Another example, identify the slope and y-intercept for each. So in this equation, we have 4y minus 2x is equal to 8. So what I'm going to first do is get it into y equals mx plus b form. So I'm actually going to add 2x to both sides, and I'm going to get 4y. Oh, let me do 4y is equal to 2x plus 8. Now I need to divide each side by 4. I'm left with y is equal to 2 over 4x plus 2. So I could also write this as y is equal to 1 over 2 x plus 2. Okay, so I'm going to look at my graph, and my y-intercept is at 2. And then my slope, I'm going to count go up 1 over 2. Up 1 over 2, 1 over 2, up 1 over 2, up 1 over 2. And now I can go down 1 over 2. Oops, that's not over 2. Down 1 over 2. Oh, wait, maybe it is. My graph's stopped. Down 1 over 1, 2. Yep. Down 1 over 2. Down 1 over 2. Over 2. Down 1 over 2. And then I can just connect my lines. And if I was better at connecting the dots, it would all be connected. Okay? And this is the equation of the line. And this is the graph of this equation. But remember, if you need to turn it into slope-intercept form right now in order to make it make sense. Here's another example where you have 7 is equal to y minus x. Well, I need to add x to both sides. So then I am left with 7 plus x is equal to y. Or another way of writing that is y is equal to x plus 7. So my y-intercept is at 7. And my slope is just 1. There's no number in front of it. In front of the x, it's just 1. So I'm going to go down 1 over 1, down 1 over 1. And then I'm going to connect my dots and draw my arrows to represent the line that's going all the way to the end. So here's an interesting one. It gives us a table of values, and it says to identify the slope and y-intercept for each. Well, we need to start by plotting each coordinate point. So we have one coordinate point that is -2, 5. Then we have another coordinate point that is 2, -3. And if you guys can notice why I chose the purple for my slope and red and blue for my x and y points. And then we have the next one as 6 and -11. So I'm going to start by plotting -2, 5. So I'm going to look at my x, -2, and then up here, 5. Then I'm going to plot my next point as 2, -3. So 2, -3. And then my next point is 6, -11. And then I'm going to connect my dots as easily as I can. And if you notice, if my line was correct, usually you would use a ruler or a straight edge. But it looks like right here is where our y-intercept is. So our y-intercept is at 1. Okay, our y-intercept is at 1. Intercept is 1. Now to find the slope, we need to do y2 minus y1. So negative 3 minus 5 divided by x2 minus x1, which is equal to negative 8 over positive 4, which is equal to negative 2 slope. So there's our slope, and if we can also look that we went down 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3, or 1, 2, 3, 4, which is negative 2. So we know that we calculated our slope correctly because we went down and over. So we went down negative 8 and over 4. Here's an example that says draw the line that passes through 3, 3, and negative 6, 0. So we're going to plot 3, 3. So we go to 3 and up to 3, and then negative 6 and 0. So negative 6 and 0 is right here. So now identify the slope. So we could do our y2 minus y1, or we can figure out that we went up 1, 2, 3. So we went up 3 and over 1, 2, 3, 4, 5, 6, 7, 8, 9. Over 9. So our slope is actually 1 over 3. And then we draw our line passing through those 2 points, and our y-intercept is at 2. The thing we're going to do is a special case. So y is equal to 2x. What that means is that the y-intercept is actually at 0. Because there's no plus b here, or plus a number, it implies that our y-intercept is at 0, 0, or at the origin. So y-intercept at origin. Okay? And then we just go up 2 over 1, and we would plot our lines. So down 2. This last special case is y is equal to 4. There's no x in the equation. So we're going to look at 4, y is equal to 4, which means y is equal to 4 throughout the entire graph. And that is the line of our equation. It's a horizontal line. When you see y is equal to just a constant, it means the line is horizontal.